Bonsoir tout le monde. Est-ce que est-ce qu'on est bien en direct? Excusez-moi, ça fait longtemps que je n'ai pas présenté. Est-ce qu'on me voit bien, Yannick?
Oui,
Oui, c'est bon.
on est
OK,
live.
bon. C'est bon, OK. Je pars. Ouais, merci. Euh, ben c'est ça, je vais juste vous mettre. OK, c'est bon. Ben c'est ça. Bonsoir tout le monde. Bienvenue à Montréal-Python 90. Uranium floral. Et ben, en anglais, c'est je vais parler en anglais. Hi everybody, welcome to Montreal-Python 90. Floral Uranium. So, mais avant de commencer, ben, j'aimerais vous souhaiter une bonne année. Ben, je sais que c'est un peu en retard, on est déjà le 17, mais on n'a pas eu d'occasion, fait que j'aimerais quand même vous souhaiter bonne année. Before starting, I just want to wish you a happy new year. I know it's a bit late, but we didn't have a chance to wish you a happy new year. So, okay, cool. And yeah, à Montréal-Python, nous avons notre, comme toujours, notre code de conduite. On veut que tout le monde s'amuse, mais avec une bonne code de conduite. Mais c'est assez simple. Le code de conduite, c'est juste qu'on veut que tout le monde soit excellent avec tout le monde. Donc, si vous voyez ou si vous entendez quelque chose qui n'est pas correct, vous pouvez soit mettre le commentaire dans notre channel YouTube ou vous pouvez nous écrire sur Slack. Mais mon équipe est là, notre équipe est là pour vous. On va essayer de régler le problème. So at Montreal-Python, we have a code of conduct. So the code is pretty simple. We want everybody to be nicely between each other. So if you guys see or hear something that not correct, you can send us a message on our Slack channel or on YouTube channel. OK. Ça c'est fait. Après ça, OK, c'est ça. Je vous ai mis deux liens ici sur juste le slide. C'est que le premier lien, c'est pour que notre after hour, quand on va finir les présentations, on a after hours. Alors, si vous avez le temps ou pas trop copier, vous pouvez nous rejoindre là. So the first link that I post here is our after hour. So if you want to join us after the presentation, you can join us to hang out. En parlant de notre after hour, j'aimerais remercier notre partenaire qui est FGN, qui nous supporte pour le serveur de Jitsi, l'application qu'on utilise. So talk about our after hour. I would like to thank our partner, FGNR, who sponsor us for the server. OK. J'ai presque fini. OK. Aussi, c'est ça, le dernier, l'annonce que je veux vous annoncer aujourd'hui avant de partir, c'est qu'on cherche des bénévoles pour nous aider à organiser l'événement ou n'importe quoi. Ce qui est important que je veux souligner ici, c'est que vous n'avez pas à savoir coder en Python. C'est qu'on cherche quelqu'un pour nous aider à organiser les événements ou organiser des ateliers, des trucs comme ça. Donc, la programmation en Python, c'est moins important ici. Mais si vous êtes développeur en Python, c'est sûr que vous êtes les bienvenus aussi. Yeah, the last announce that I want to talk about is we are looking for volunteers to help us to organize our events. Like we're gonna have like the programming workshop to come, and we're gonna have a lot of event to come. So we need we want more volunteers to help us to organize. And you don't have a skill of Python to organize our event. So if you don't have a skill, you are welcome. But if you have a skill for Python programming, you are welcome too. So yeah, enough about blah blah. I gonna kick this one off with Nicolas. Just let me see if I can bring Nicolas here to say hello to everyone. Hi, Nicolas.
Hi, everyone. Can you hear me okay?
Yes, I hear you correctly. Oh, yeah. Sorry. Just let me make a small intro. Sorry, I forgot that. Yeah, Nicolas is head of data visualization at Plotly. And c'est ça. Mais je veux souhaiter bienvenue à Nicolas. Mais Nicolas, ça fait la deuxième fois. Il n'est pas nouveau chez nous. Oh, la quatrième fois déjà. Oh, wow, je pense que j'ai manqué quelque chose. Mais bon, OK. Oh, ça fait toujours plaisir de revoir. Peut-être que je n'étais pas encore là quand tu as fait les présentations. Mais bon, bienvenue à notre... re-bienvenue encore. Bon, check, je te laisse te présenter un peu, Nicolas.
Merci beaucoup. Hi, everyone. Yeah, my name is Nicolas Kruchten. I'm actually the former head of data visualization at Plotly. I am now the sort of volunteer open source maintainer of the Plotly library. And I've actually pre-recorded my talk tonight just to make sure there's not too many disruptions with kids running around and stuff. But I just wanted to say hi. We're going to cue my video in a second. It's about 20 minutes long. And then I'm going to be back here to take any questions or comments or just chat about things for 5-10 minutes after that. So thanks very much for being here, and thanks for having me back, Montreal-Python. It's been a bit of a rough ride getting this talk scheduled. It was scheduled for last month, but here we are, and thanks for letting me pre-record. So, Duke, if you want to play the video, I'm going to close my camera, but I'm around, and I'll be back at the end.
All right. See you later, Nicolas. Yep.
And thanks for having me here back at Montreal-Python. Today I'll be talking about a fresh look at the Python data visualization landscape. So as maintainer of the Plotly library, I'm part of the global sort of loosely knit Python data visualization community. And we have this website called pyviz.org, which is a community-driven website. It's essentially powered by a YAML file, and it's sort of updated every day via automation. And it says here, if you're part of the visualization landscape, be it a maintainer or a user, this is your site. And it's basically a resource to help folks find their way among this sort of crazy ecosystem that we have for doing data viz in Python. So if I look at all tools here, this will provide a sort of justification for me saying it's this sort of crazy world. There are a lot of tools for doing data visualization in Python. If I scroll down this page, there's maybe 100. And so this page, this all tools page here, is a bit of a registry for all of the viz libraries that exist in Python. And it's bucketed into a number of different headings. So you've got some core libraries here. Plotly.py here is the one that I maintain. And there's some information to help folks basically figure out, sort of how popular these libraries are and how likely they are to get some help. So in terms of how many stars there are on GitHub, how many contributors there are, how often these things are downloaded a month, and then what they're built on. So you can see that some of the non-core quote-unquote libraries, like the high-level libraries or the native GUI libraries, some of them are built on top of some of the core libraries. So you can see here, it says built on top of Matplotlib. Not technically entirely true at the moment, because pandas, if you call pandas.plot, you can target a number of different libraries. But there's sort of some structure here, right? Some of these other libraries are built on top of the core ones. And then some of the headings here include, high-level libraries, for working with data in a sort of terser way, native GUI libraries for building desktop applications, scientific libraries for visualizing real-world data, like 3D data, geospatial libraries for making maps, and so on. So this is a pretty useful page. It's a little overwhelming. And so there's a page called Overviews, which provides a number of links to various blog posts and conference talks that have been given that sort of try and compare and contrast these different libraries to give you a sense of what it's like to use them. And then at the top, there's this diagram. Now this diagram is an adaptation of a graphic that was first presented at PyCon in 2017 by Jake Vanderplas, and it's sort of a conceptual look at the Python data viz landscape. You've got a number of categories like Matplotlib and libraries that are sort of related to Matplotlib, JavaScript and libraries that sort of use JavaScript, including libraries that use D3.js, which is a specific JavaScript library. And then there's a number of systems that use OpenGL for direct access to a graphics card. So on and off over the past few years, I've wondered if there's a sort of different way that we could present this same information and kind of combine some of the taxonomy from the All Tools page and some of this sort of box and arrow visualization of the Python visualization landscape. And that's what I want to talk about today. I'm not kind of completely done with my diagram, but it's done enough that I want to share my sort of work in progress with the broader Python community here at Montreal-Python, and eventually, once this is on YouTube, with the broader Python visualization community, and get some feedback to see if maybe this is a diagram that could sit here alongside this one. So let me show you my diagram. The question that my diagram is meant to answer is sort of what goes in between some application-specific Python code that maybe you are writing and a user that wants to look at some visualization. So the Python code is going to produce a visualization that the user is going to see and interact with. Now, this user could be somebody else. It could be a customer. It could be a user, a colleague, or maybe it's you. Maybe you're writing some Python code to visualize your own data, and that's totally fine. So the easiest way to do that, the easiest way for some Python code to produce a visualization for a user, I would argue, is for that Python code to basically write a file to disk in one of these formats, like a PNG file or an SVG file, and for the user to open that file in a viewer or editor. So if I'm on macOS here, I could open that up in preview and look at it. So that's probably the easiest thing to do. And you'll notice that these arrows here are unidirectional. So once my Python code has produced my raster file and I'm opening it up in an editor, if I click on that PNG file, my Python code doesn't know anything about that, right? So this is sort of a one-way flow. Another way that Python code could produce a visualization is by opening up a native window, say a macOS window, and drawing into it. And then when the user sees this window, they can click in it, they can pan, they can zoom, and these arrows are all bidirectional because whatever intermediate library it's being used to generate this window can actually capture these events and sort of forward them back to the application-specific Python code. So you can build really rich, interactive, full applications in Python that render interactive data visualization using any of these toolkits. So for a long time, this was kind of the way things worked. But obviously, over the past, say, 20 years, a whole new kind of window has become more and more popular. You may have heard of them. They're called browsers. So web browsers, like the one I'm currently using to display this particular visualization. The easiest way for Python to interact with the browser is for your application-specific Python code to write an HTML file to disk, and then for the user to open up that HTML file in a browser. And then you get a lot of the same characteristics as when you're opening up a raster or a vector file, except that the browser is pretty smart, pretty dynamic. And so this HTML file, when it's being rendered in your browser, can be quite interactive. Maybe you can pan, maybe you can zoom, maybe you can hover on things, within the browser, right? At this point, the application code is out of the picture because it's written its file to disk and it's done. If you want to kind of close the loop and have your application-specific Python code be able to retrieve the events from the browser, you have to use some different technologies. Here I've listed some of the visualization-specific technologies that exist, sort of Jupyter, Voila, Dash, which is related to the Plotly library that I maintain, Panel, Streamlit. Obviously, I could put Django or Flask or FastAPI here, but those are not data visualization-specific systems, and so I've left them out of my diagram. So this is kind of how I think of the technological landscape that visualization libraries in Python face, right? You've got some application-specific code over here. You've got a user way over here, and here's a bunch of technology that can be used to talk to that user. And so here now, finally, I can draw a number of the Python data viz libraries. Now, obviously, I'm not trying to make a complete map here. This diagram's already quite busy, so I've chosen the most highly used and the sort of most representative ones for this particular diagram. And what I've done is I've basically laid out, who talks to who and how. So let's start with looking at sort of mighty Matplotlib here in the middle. It's the most downloaded and most used visualization library in Python, and this diagram will maybe help show you why. So if I look at all of the arrows that go into and out of the Matplotlib box here, you can see that Matplotlib kind of downstream talks to almost everybody, right? So let's kind of unpack this. Matplotlib has these unidirectional arrows to produce raster and vector files, which can be opened in a viewer editor, no problem. Matplotlib can make visualizations that can talk to a whole bunch of these different toolkits and open native windows and have this full bidirectional flow. So Matplotlib is aware when a user clicks on something in one of these windows. Matplotlib can also be used to render figures in Jupyter in both the static mode and with a Jupyter widget. So you can actually have bidirectional interactive communication between a Matplotlib figure in Jupyter and the Matplotlib process itself. And then with these other dashboarding frameworks like Dash and Streamlit and Panel, as far as I know, and I could be wrong, this world evolves really quickly, it is definitely possible to display Matplotlib figures in these frameworks, but as far as I know, it's not possible to send those events back to Matplotlib at the moment. So that's Matplotlib downstream. It talks to almost everybody. The one thing that Matplotlib doesn't do, as far as I know, is produce HTML files, interactive HTML files for rendering in the browser. But okay. Upstream, there are a bunch of libraries that are essentially clients of Matplotlib, right? Seaborn, very popular, very well known, statistical visualization library, basically produces Matplotlib figures. Plot9 is much the same. CartoPy for making maps is much the same. And then the more generic sort of statistical visualization libraries like the .plot API in Pandas or HoloViews can also produce Matplotlib figures. One thing to note is that none of these arrows are double-headed. So if someone, in a native window or in a browser clicks on something, Matplotlib is aware of it, but it doesn't have a way of forwarding those events back to pandas.plot. So if you think about your application-specific Python code, it can actually call into any of these boxes, right? Arguably any of these boxes. I didn't bother drawing those arrows, those rightward arrows from your application Python code into every box, but that's you can sort of mentally fill those in. And any arrows that go back towards the left, the libraries that capture that receive them can forward those back to your application-specific Python code. So the way to read this diagram is that my application code can call Seaborn, and the output of that can go to Matplotlib, and then Matplotlib maintains a relationship with Jupyter widgets via Jupyter into a browser. And if a user clicks on something, then this arrow is double-headed, and so is this one, and so is this one, and so is this one. But if my application-specific Python code wants to capture that event, it's got to subscribe to some Matplotlib. So that's Matplotlib. It's mighty because it basically does everything. There are other libraries out there. So if I look at the sort of bottom third here, there are some dedicated scientific visualization libraries like Mayavi for 3D, Napari for image processing, Glue, which comes out of the astronomy world. And these are basically specialized architectures for specialized workloads that talk directly to a local graphics card to process larger data sets. And these tend to open native windows. Now, we sometimes call these desktop windows or desktop applications, but that's a bit of a misnomer because I don't actually have to be sitting at the same desk where the machine is running. I can actually be running one of these processes on a remote machine, on a very powerful machine somewhere in the cloud, and then talk to it either via remote desktop or via X forwarding. And so you can in fact use these in a sort of client-server way. Much like a browser, but the thing that these libraries all have in common is they're all bidirectional. They all have a bidirectional communication with a native window that's owned and operated by the Python process. So when the Python process shuts down, this window disappears, and the interaction is largely mediated by Python code that's running in one of these libraries. So what about browsers? Well, I'm not going to go into all of these different libraries. I'll talk mostly about the one that I know best, which is Plotly, and it's broadly representative of the others. So if I look at what Plotly connects to, Plotly is a Python library. I can use it to produce graphics, and I can make raster and vector files that can be opened in a viewer. Plotly can export HTML files, which are openable in a browser. Obviously, you can use it from Jupyter. And if you use just fig.show in Plotly, you get this sort of unidirectional connection to Jupyter, where the figure is pushed to the browser, but the Python process can't get any events back. If you want to write some Python code which captures user events from a Plotly figure within Jupyter, you can use the Jupyter widget system, the figure widget, and within any of these more modern dashboarding systems like Dash or Panel or Streamlit, you get the events back to Plotly. Upstream, some of the same things that talk to Matplotlib also talk to Plotly. So HoloViews will produce Plotly figures, as will pandas.plot. The output of datashader can be piped into Plotly as well. The same sort of observation can be made about Plotly as I made about Matplotlib, is that none of these arrows here are double-headed. So if I want to capture events from a user clicking on a Plotly figure that's been produced by HoloViews, I got to talk to Plotly and not HoloViews about that. In some cases, actually. That's not entirely true about HoloViews. So this gives you a bit of a flavor of how to use this diagram. Now, I'm doing my best to sort of fill all these in. I haven't filled in all the bokeh arrows. I haven't filled in, all the BQ plot arrows necessarily. But this is the basic idea behind my diagram and why I've laid it out this way. So a couple of observations and limitations about this diagram. One, as I've mentioned, not every library is here. But I hope that a cursory look at the documentation for any of these libraries would help sort of mentally position them in one of these sort of areas. You can kind of look at the docs and see, oh, okay, this library is mainly oriented around producing native windows. Maybe it's down here as part of this cluster, and it's built on top of WX Python, so I could have an arrow here. So that's one thing. And secondly, there are some Python modules that exist, or open source projects that aren't boxes in this diagram. They're actually arrows. So these two arrows, from Plotly to raster and vector, you need to install a separate dedicated Python package called Kaleido to do that. If you want to go from pandas to HoloViews, which is something that's possible, you have to install hvplot, which is fine. It's just that the hvplot package doesn't get its own box here. It sort of represents this arrow. So that's another kind of observation about this diagram. So I spent a long time sort of showing boxes and arrows and talking about a bunch of stuff, but this is a Python meetup, so maybe it's time to actually look at some code. Let me kind of show you concretely what this looks like if maybe you're less conversant with some of these. So let's actually go back to the Matplotlib connection. So what does it look like if I write a script that's over here, and it calls Seaborn, which calls Matplotlib to kind of write a raster file to disk and open it up in a viewer editor program. So any path in this diagram is actually a Python script. You could actually write a Python script to represent any one of these paths. So let's actually take a look at what that looks like. I'm going to be right over here in JupyterLab, and here's a really simple Python script that loads up Matplotlib. Actually, I don't need this as part of another part of the demo. Loads up Matplotlib, loads up Seaborn, uses Seaborn to make a to make a plot, and then calls a Matplotlib function to save it. So if I actually run this script, okay, thinks about it for a sec, and then I actually load up this PNG. All right, so I can click on it all I want. Not much will happen. It's a PNG file. I mean, it's being served through my browser, but in this sense, my browser is essentially operating just as a naive viewer. So far so good. That's my one path. What if I want to show the Seaborn to Matplotlib to a native macOS window and show some sort of interaction? I can do that too. Here is, here's my original script. Here's a slightly augmented version of that script where I've got the same plot. I'm going to use the MPL cursors library to add some hover labels, and I'm going to call plt.show instead of plt.savefig. So if I run this script again from my command line, so I'm running this in a browser just to save on the window switches. But if I run this script, you can see here that I've actually opened up a native macOS window. And this is interactive. I can resize it. My plot is resizing. I can hover. I've added these hover labels. If I want, I can pan. this around. I can zoom with a zoom box. I can continue hovering. I can go back. I've got a whole bunch of different options. So this is a native GUI window that's running. And if I switch back to Chrome, if I switch back to Chrome, you can see that my script is still running. And when I actually close this window, then my script will terminate. So the window is open as long as the script is running, and the script is running. Well, it doesn't do anything after the window closes. So the script is running as long as the window is open. So that's a pretty good example of a path from Seaborn down to a native window. And actually, Matplotlib has this swappable backend system, so I can do the same thing and show you the same plot through this Jupyter widgets box through Jupyter in a browser. So this is why I'm running this stuff in Jupyter Lab. I open this stuff up in a notebook. If I call Matplotlib widget, I can run the exact same script, and now plt.show, instead of opening up a native browser window, opens up a Jupyter widget. And now, whenever I hover, I still get my hover labels. That's because this Python function is being called, and this is still fully resizable. I can pan, I can zoom, but now I'm in a browser. So that's pretty nice. So much for this sort of Matplotlib based stuff. What about the Plotly based flows? So I'm going to make the same figure going through this time the repr HTML path in the browser. So if I pull up this Plotly code, it's very similar to the Seaborn code. I am once again rendering a figure in the browser, except this time when I'm hovering, I didn't have to write any Python code to do that. And I can tell you that this hover is entirely being done in JavaScript. So I could actually kill my Python kernel here and these hovers would still work. In fact, let's do that. Let's interrupt the kernel. And these hovers still work. And I also wrote this to an HTML file right here, fig.html. So if I open this up in a new browser tab, Python is definitely out of the loop here. There's no more Python left, but the hover still works. I can still zoom. I can still reset and double click. And so that's a pretty good example of Plotly to the document HTML back to the browser view. Now, I don't have time in this talk to go through and show all of the different examples. But hopefully this is sort of illustrative of the fact that every one of the lines on this diagram essentially represents a Python script. And my hope is that I can sort of finish this diagram and maybe add this as a resource over here in the overviews to PyViz to basically help folks understand the paths that are available to them and how to exploit those paths. So how to write the Python code that actually corresponds to all of these different paths here. So the reason I presented this is because I really do want feedback on this. Like, is this too complicated? Is this helpful? Are there arrows missing? Are there things that I'm not thinking about? Is there a better layout that reduces, the number of crossings, and so on and so forth? So this is sort of me presenting a work that I consider, about 80% done, and I would really love some feedback on it. So if you visit here bit.ly/pyviz diagram, you've got the actual draw.io file that I'm using to build this. So draw.io is an open source build graphics tool. You've got the little code snippets that I've put together, and you can actually view this diagram online right here. There's a link. And if you want to get in touch with me, after this talk, I'm available on Twitter. I'm available on GitHub. You can send me an email. I have a blog where I collect a bunch of different talks that I give. I am now a grad student studying at ETS, doing research on data visualization APIs. So I am more than happy to talk to anyone about Viz anytime. And I've left some time now for questions or comments if anyone wants to chat about this diagram. So thanks very much for listening to my talk. And I'll take some questions.
Okay. Yeah. Okay. Let me bring back Nicolas and Yannick, who will take care of the questions. Thank you, guys. See you later.
Thanks.
Thank you, Nicolas. And everyone, please, if you have any questions for Nicolas, you can ask them in the live stream chat on YouTube or on Slack. We are in channel meeting. Tout le monde, si vous avez des questions pour Nicolas, vous pouvez les poser dans le chat de YouTube ou sur Slack. On est dans le canal Meeting. Et on a une intervention ici qui est... thank you, Nicolas. C'est pas une question. Donc,
My pleasure. Thank you.
Thank you, Nicolas. I have a question while people think of their question. So, and it's about data presentation. So you did a really good job of mapping like the pipeline that the data has to go through the code. But let's say I have some data, like the breakdown of how I spend my day, and I want to present that. How do I go the other way around? Like, so first deciding what the data should look like to be intuitive to my users, and do you have resources for that? So some people often recommend Tufty. I think it's a little bit dated. It's really good at telling you not to use PowerPoint, but we know that by now. So what's your take on this one?
Yeah, that's a really good question. So, the diagram that I've presented is very sort of technically oriented, kind of explaining how the pipes work. In terms of actually sort of deciding which visualization to do before choosing a tool, which I recommend. I mean, definitely there are a whole bunch of resources out there that exist. Some really good ones that I like are books that are written by Stephen Few. FEW, so he's written a number of good books. I think Show Me the Numbers is the one that comes to mind. It's quite good about a sort of very minimalistic way of presenting data. There's also an excellent book called Storytelling with Data, and there's a website with sort of a community where they kind of do challenges. And if you want to get better at sort of getting creative and thinking about how to visualize data sets, there's also a number of sort of Twitter threads like Tidy Tuesday and Makeover Monday and various various groups that sort of get together and chat about how to do this stuff. But definitely that first stage is very, very different and less sort of technical and more of a sort of design kind of stage in terms of thinking about how you want to visualize your data. The one thing I'll add is it's important to not fall into the trap of thinking that there is only one way to visualize your data. You actually probably, the best recommendation I can give you is to sort of step even further back and say, what is it that I want to do? So it's not like you have a data set and there's like one best way to visualize it. You basically have to think about what is it that you want someone looking at that visualization to get out of it. Do you want them to get a particular insight? Do you have a message? Do you want to enable them to notice a particular kind of pattern? Those will all kind of feed into how you choose to design your visualization, and then probably will feed into, do you need something highly interactive? Do you need something that runs in a browser? Do you need something that connects back to a mainframe to do some heavy number crunching, or is just a PNG fine? In which case, you have a much bigger menu of possible libraries.
Excellent, very good. Thank you so much. We have a question here from JP Brochu. Is there a way to use Plotly Dash without an internet connection? And a follow-up that is a clarification actually, as a standalone file, but with the interaction. Yeah.
I think I understand the question. So it's definitely possible to run a Dash application locally, much like I was running the sort of Matplotlib script locally on my machine. I'm not sure I really understand the nuance of the question. So there is no sort of standalone viewer. You can't basically email someone a Plotly Dash file and have them loaded up. There was actually a talk. I can't remember which Montreal-Python it was, like 65 or something, where someone showed a way of essentially bundling a Dash application into an Electron app. So it sort of came with a Python backend and a browser, and you could sort of distribute that. It's a little bit involved, and I don't know if there's any good recipes for how to do that other than that one talk. I'm not sure if that answers the question you're asking, but those are the things that come to mind.
Excellent. And now a question from Christian Hudon. Super useful diagram. The main comment is that it should be interactive, so clicking on some of the boxes to highlight the path. Do you have any plans to bring that to that level?
Yeah, so that's the part that I'm kind of struggling with. I started drawing this diagram, and then I was like, "Whoa, arrows!" And so, you could see during the talk, I was kind of clicking through various tags, and so I don't know whether the best thing to do to be able to click on the boxes and to sort of see the downstream arrows, or perhaps just to put on the PyViz website kind of a GIF that kind of cycles through, showing the various cycles, and you can kind of pause it and take a look. That's definitely kind of the current sticking point. I can't just turn all the arrows on, because then it's a big mess. So definitely I'm kind of trying to think about how to do that. The trick is I also want to not build a super custom JavaScript or Python visualization, because I want people to be able to contribute to it and easily add an arrow. So I don't want to make something really idiosyncratic. But that's definitely where the challenge is right now.
Excellent, thank you. And that seems to be all the questions we had. Let me double check on Slack. Just a moment. And yes, that covers it. You've answered all of our questions today. Thank you so much, Nicolas.
Awesome. Well, thanks very much, and please feel free to reach out if you have any questions or ideas or thoughts after the fact. I'm really happy to discuss them. I want to make a more useful resource for everyone. So thanks for listening. Have a good evening.
Thank you.
Thank you, Nicolas and Yannick. Ok, c'est bon. On va continuer avec notre prochaine présentation. C'est Mariatta, qui est une développeuse depuis, elle a plus que 15 ans d'expérience. Et en ce moment, elle travaille pour Google comme développeur, senior développeur. Et c'est ça, Mariatta, habituellement, elle habite à Vancouver avec son mari et ses 2 enfants. So our next presentation is going to be by Mariatta. She has like 15 years of experience as a developer, and for now she's working at Google as a senior developer, and she's living in Vancouver with her husband and 2 children. So I'm going to bring Mariatta here. Hi, Mariatta.
Hello. Hi.
Okay. Yeah, I let you take the control of the whole thing. Okay.
All right. Thank you so much.
Okay.
Can you all hear me? Okay.
Yes. We hear you correctly. Yep.
Okay. Let me see about sharing my screen properly here. This is the right screen. Let me see. What do I go about doing this? Where is my slides? Hold on. I got it all set up and now everything's gone.
Okay. Okay, good. Yep. Now we see you.
Yeah. Okay. All right. Okay.
Okay. See you.
Here we go. Thank you. Hi, everyone. Thank you so much, Montreal-Python, for having me here today. I'm going to talk to you about unit testing and continuous integration. My name is Mariatta, and I live in Vancouver, Canada. And you can find me on Twitter and GitHub as Mariatta. I currently work as Senior Developer Relations Engineer at Google for Google Cloud Database. In my free time, I contribute to and maintain open source projects. I'm one of the Python core developers, which means I'm the maintainer of one of the most popular programming language out there. So, unit testing. Unit testing is important. You should do this. If you're a software developer, you're a software engineer, you write code that will be used by other people, you have code that will go into production, then you should write unit tests. Now, I know that you're not gonna start writing tests just because I told you so. Like, you've probably been told by everybody, you need to write unit tests. But let's try to understand why this is important. Especially when I was new, like I didn't understand why we need to write unit tests. In my first job as professional software developer, I got paid to do programming like a long time ago. We didn't write tests. I didn't start writing tests until my third job, until I started writing Python. And then like I was told to start writing unit tests. So that doesn't mean that we didn't test our code. In my first and second job, we test our code, not with unit tests. We test it manually. Like we would run the code, run the program, like deploy it, run it and try out every single functionality. We would do this big testing day, like once every 6 months. And at that time, we actually have like a big document of 100 pages that describes all the test cases. This kind of manual testing is time consuming, and it's boring. Like, it's boring and repetitive. So we don't want to do lots of manual testing just to make sure the code works. So writing unit tests is a way to automatically test that your code works. Like, you write unit tests for the same reason you do manual testing, just to check that this code works. So I have this example here. Say I have a function that is super simple. It adds two numbers. So how would you test this code if you don't have unit tests? You would run it, right? You would call the functions, and you would call this function, print it out, you read the output and verify, yeah, indeed, 1 plus 2 is 3. So now I know the code works. So that's a manual testing. Programming language like Python comes with its own unit test framework for you to write automated unit tests. So the unit test module is built in Python. You don't have to pip install anything. If you have Python, then you can import the unit test module. You can start writing and defining your test cases. So in your test case, first import the unit test module, and you will actually import the function, the code that you wrote. You will create a test case, call that function, and pass the parameters. So to actually test the function, you would make an assertion saying that assert that the output of this function will be equal to the value that you expect. So in this case, 1 plus 2 should equal 3. And when you execute the test, you will see a kind of a report. It would say that the test was run, that everything is okay. So this is an example of running a test where the test is passing. So this is another example of running a unit test where the test actually failed. Here I changed my test case, saying instead of expecting that 1 plus 2 equals 3, I wrote in my test that 1 plus 2 should equal 12. So when I run the test, I would see an assertion error. It is saying that the value I expect, 12, does not equal the value returned by the function, and that's why the test failed. So when tests failed like this, I should be looking at my test and my code and figure, like, was it the code that was wrong that not returned the expected value, or was it my expectation of the code that was wrong? So this is another reason why you want to write unit tests. You want to test your code against various inputs and scenarios. Like, maybe you want to test whether your code handles negative numbers, decimals. You can write tests for those. And the other reason why you want to write unit tests is to find bugs with your code. As you write the test and thinking about the different inputs, scenarios, edge cases, maybe you even discover a bug while testing, and you can therefore fix your code to be more reliable. Using this example, like, what if we're adding two letters like A and B instead of numbers? So what do you expect from your code here? Should it pass? Should it return me AB, or should this fail, right? Should this raise this exception? So I would need to adjust the code to handle these kind of situations. And what if one of the input is a number and then the other is a letter? What is the expectation? The code will raise an error. So maybe you want to go back to the code and write the logic to handle this kind of input. And if the code raises an error, and you can test for that error is raised in this case. So for example, if I go back to this function that I wrote, and now I'm saying, well, I only want to accept numbers if the caller passed me the letters A and B, then I want to raise an error. So in this case, I raise a value error. So now when I write the test for this, I want to ensure that the error is indeed raised if they put in letter instead of numbers. So I can do this by using the assert raises. So writing unit tests like this will help you discover issues like this during development, and it will help you improve your code to be more reliable. Unit tests also work as documentation about your code. Unit test gives information of how your code works. So if somebody else is reading the code and wanted to understand what it does, they could read the unit test. They could see how to use your code, how to call it, how to set it up. They could see your different test cases in order to understand what the constraints and limitations of your code. So writing unit tests is tedious. Like initially I wrote very few lines of code. I have like 5 lines of code and ended up with 5 times more code in the form of unit tests. But this is actually important. Like having unit tests will help when we want to modify or to perform maintenance of the code. For example, the new Python version is out. Maybe you've been working in Python 3.6, 3.7. Now that we have Python 3.10, and I wanted to know, will my code work with Python 3.10? So in order to find out, I would run the test. I would run my code, my 3.6 code, against the Python 3.10 environment. So if my test passed in 3.6 but fails in 3.10 is possible, that means my code is not compatible and I need to go and fix it. So you can use your test to catch deprecation warnings. In Python, you would see deprecation warnings to let you know when certain features will be deprecated, that it could be removed in the future versions. So if you want your code to work in future Python, in newer, we will have 3.11 coming later on, you're going to test and you're going to have to adjust your code accordingly. Maybe you need to stop using whatever feature that's being deprecated and use something else. In your unit test, when you run your unit test, you can add the -w flag to see the warnings. And when you see these kinds of warnings, then you know there is incompatibility with your code with a newer Python version. So you're gonna go and fix it. Otherwise, your code will not work later. And another reason why you should write unit tests is that so that you can have continuous integration as part of your process. Continuous integration is the practice of using automation to frequently integrate and merge code changes into a single project. So that's the next part of this talk. Let's talk about continuous integration. Continuous integration, or CI, is considered best practices for DevOps. And you should do this. You work in a team, you open source your code, you do open source contributions, you have more than one contributor working in the project, you should have CI as part of your workflow, as part of your process. And again, maybe you're wondering, like, why is this important? And because integrating code, merging code changes is actually costly. It takes time and effort. You could be introducing bugs by merging new code, and it could break existing functionality. So instead of thinking, why do we need CI? You've got to think about, what if we don't have CI? So let's imagine you're in a team, you're working on one feature, your coworkers working on a different feature, and then one time they said they're finished, they made a pull request and asked you to review so that it can be merged. So as the reviewer, you gotta decide whether this code can be merged. So how do you decide? You're gonna review the code, read it, and then you ask questions about the code. Like, you wanna know, does the code work? Like, does it do what it's supposed to do? Right? You wanna read the requirements and ensure that everything is met. You're gonna ask, like, okay, what are the constraints and limitations about this code? Does this handle exceptions? Does it cause exceptions? Does this break anything else? Is this compatible with the rest of the software? And bonus questions you should also ask, is this code documented, right? So how do you answer all of these questions? You can take the code, try it out by yourself, run it, try out different things, or you check if there are unit tests that cover all of this. Then if they have unit tests, you want to actually run it and make sure the test pass. So running unit tests itself, though, is not straightforward. You first need to get the copy of the code from your coworker into your local environment. You now need to set up your local environment, install dependencies, make sure the code is running, and then you run a test, wait for it to finish, and then you view the result. Then you need to do all of this all over again for the next pull request from another team member. And you have to do this though, like this whole process needs to happen because you want to be certain that you're building and delivering code that meets quality standards. So merging code is costly and risky. In order for you to be more agile, to speed up your development cycle, you need to automate this. So if you have a CI, you can have a process that will automatically grab the copy of the code changes. This process can automatically set up the necessary environment, and it can even run the test automatically. So all you have to do is now just to ensure that the CI ran and then the test passed. So now you can just simply click the merge button. And there are various ways to add CI as part of your process. There are lots of options, and depending on your platform, if you're using GitHub, you can use Github Actions. If you're on GitLab, you can use GitLab pipelines. And there are various vendors that support CI as part of your workflow, such as Circle CI, Travis CI. You can use Jenkins as well, and there are lots of options for you. So I want to just show how to do this, how to set up CI with GitHub Actions. So on GitHub, you would be setting up GitHub Actions by adding a YAML file and in the same repo of where you want the CI to happen. And it has to be added under the .github/workflows directory. So the YAML file contains a set of instructions to tell the CI on how to run the test for the project. So I actually have a sample repository that you can look. You can go to the URL here to check out the entire setup. So in this repo, you can see that there is the GitHub workflow/CI YAML file, and I'm putting in here just the snippet. The longer version, you should go to my repo to see it. But just to show you an idea. So if you look at the steps section of this file, that's where I'm telling the CI on how to run the test. I'm telling it to first install the dependencies. It does the pip install, and then I'm telling it to run the test by calling the python-m unit test, which is the same command line that I would use if I'm testing it locally on my machine, python-m unit test. And you'll notice that there is a line in under the strategy, the Python version, where I said, Python 3.8 and 3.9. This is where I get to tell the CI that I want to test this against the different Python versions. So if I want it to be running Python 3.10, I should add 3.10 to this list. So this is how I can make sure that my code is compatible against the different Python environments. And because I'm letting the CI to set up the different versions, I don't need to deal with this manually. Some of you might have tried installing different Python versions in your machine. Sometimes it screws things up. It's complicated, right? This way you get the CI to do this for you. And I can do more with CI. It's not just about running unit tests. You can run other things. For example, if it's part of the measure of quality for your code is that if you follow certain coding style, say if you use things like Pylint or Flake 8 or Black Auto Formatter, and you want to make sure that any code that gets committed complies to those standards. You can include this as part of the CI. So this is an example code where I'm checking the code if it complies with Black Auto Formatter. So in this step, I added the installation setup. I'm telling it to install the Black package and then run the Black -- check to make sure it's being run. And I can also use the CI to check for coverage. In this example, I added the job for running unit tests and then running the coverage report. So all of these tests and checks will automatically be run whenever anyone makes a pull request to this repository and whenever anyone wants to make changes to the repo. So since I want to ensure a certain quality standard, I wanted to make sure that these checks are passing before I would merge it. Now that I know the code works, it doesn't break anything, it's following a certain code style, I can simply click the merge button confidently. So that's the introductory. The introductory examples on unit testing, and there are lots of resources out there for learning more about how to write unit tests. You can read the documentation on unit testing on docs.python.org. There's a pretty good tutorial. There's lots of tutorials out there. Here's an example that I found quite useful. Introductory tutorial on Python unit test module on YouTube by Cody Schaffer. There is also really good in-depth article about this from Real Python. And as you do more unit tests, you will start doing integration testing, or you might also test using third-party application or third-party systems, third-party API. You may come across the concept of mocking when writing your test. And so Python comes with its own mock object library that you can use. For those, I'm going to try to explain what is mocking if you're not familiar with this. So like one of the reasons you write tests is to test that your code works. Right? You call a function and it does what it's supposed to do. So what if the code actually interacts with external systems? So like maybe your code will charge customers' credit card. Your code will print something on a paper. You don't want to actually execute these functionalities. You don't want to actually charge customers' credit card each time you run the test. You don't want to print the printer to print something on a paper each time you run the test. It's wasteful, right? So on these kind of scenarios, you will still write tests, but you will mock the calls. You fake the calls to those external systems. So mocking and patching is actually pretty powerful tools in unit testing. You will eventually need to use this, and there are really good tutorials out there on how to do it. So there's a great article from Real Python called Understanding the Python Mock Object Library, and there's also a great talk by Lisa Roach. It was given at PyCon US a few years ago called Demystifying the Patch Function. Another useful testing framework is PyTest. So this is a third-party library, so you need to install it separately. You need to do like pip install PyTest. So this is pretty powerful testing framework as well. I recommend learning about this. I've been using PyTest at work and as well as at various open source projects that I contribute to. People are using PyTest. So there is a great tutorial about this topic in Introduction to Unit Testing in Python with PyTest that was given in PyCon US by Michael, Tom Wing, and Christy Wilson. And once you do unit tests, integration tests, then you're probably going to be doing end-to-end testing. So in end-to-end testing, not only you're going to test a single unit, not just a single function, but you'll be testing the entire workflow from start to finish. So there is a great resource, a great tutorial that you can read about in Free Code Camp. And one of the framework that I've used in the past for end-to-end testing in Python is called Selenium Python. So I've shared the documentation for it so you can learn about it. So now that you've learned about unit testing and CI, continuous integration, you understand the importance of this, you know how to do it, do it. Write unit tests, have CI, have coverage, have 100% coverage if possible. So improve your code base. Thank you so much for listening, and thank you again, Python Montreal, for having me here. I really appreciate your feedback about this talk. So feel free to get in touch. You can find me on Twitter. I'm on GitHub. I'm on LinkedIn. I'm on Polywork. I'm everywhere. So you can get in touch with me. Thank you again.
Thank you, Mariatta. Yeah, let me bring back Yannick, who gonna take care. Hey, Yannick. So thank you, guys. I let you guys take care of question.
Excellent. Thank you again, Mariatta. And everyone, you can ask your questions directly on YouTube or in Slack, and I will relay them to Mariatta. Tout le monde, vous pouvez poser vos questions en français ou en anglais, ça va me faire plaisir de les traduire sur YouTube ou sur Slack. And while you're preparing your questions, I have a question for you, Mariatta.
Yes.
So you mentioned go to 100% coverage. To me, that seems like a lot, but maybe I'm not focused enough. So in your experience, like when do what is enough coverage to say I'm good for now, and you know, maybe I'll get back to it later, or like is 100% the only acceptable answer here?
I try to have 100%, but yes, I do agree. In some situations, it's hard. I've seen code bases that only have like 30%. That's too low. Like you need coverage. I think you should at least aim for 190. I've seen 90 to be acceptable by some companies. You know, it's what you're comfortable with. I do want to share one code that I heard from Ned Batchelder, who is the maintainer of coverage py, and I think he said one time that when you have 90% test coverage, you don't actually know what 10% of your code actually doing. Like when you don't have the coverage for those, you have no idea what is working on, right? What it does. That's why, and that's for if you're maintaining code, you want to do upgrades, especially like if you're upgrading your code from 2, if you're still doing that from 2 to 3, or even from 3.8 to 3.10, you know, if you don't have that full coverage, it's hard to know whether your code will really work in the newer version. So try your best to just really have lots of coverage. I'm not gonna tell you like 80 is good, 8 or 70 is good. Just do your best to do a lot of testing.
Excellent. Yeah. Very good. We have a question from JP Brochu, and that is, does unit testing is better suited for object-oriented programming or for functional programming?
I've used unit tests for both cases. For functional, I think in Python itself is good for object-oriented or functional programming. Like you can use both styles with Python. So I would say use it for all of them. Yeah, it's suitable for both. Yeah.
Very good. And that might be all the questions we have right now. Don't hesitate, everyone. If you have questions, you can ask them on Slack or on YouTube. Let me double check. That seems to be it.
Okay.
Right. Wait. We're not done. A question from Andrew Francis. Andrew Francis is new to CD. I want to trigger unit test when I merge a feature, which is like very similar to what you talked about. Then Dockerize before staging. So a little bit more involved than just checking out the code. So what would be the tools that Andrew should be using for doing something like this?
You can totally do this on GitHub using, I believe even Github Actions is supported. Basically, if you want to trigger something to happen after you merge, there are webhook events from GitHub that will tell you that something has been merged. Now you can run the test. So this is supported on GitHub. You can use GitHub Actions. You can also use Jenkins.
Excellent.
Yeah, so it's not about the tool, but utilizing the webhooks, the on commit webhook from GitHub.
Excellent. So GitHub or Jenkins would be areas that Andrew should look into. Thank you. And a comment, well, a question from Joanne Mpo. Where can we get all the links of resources that you mentioned in your talk? There were lots of very interesting links.
Yes, I do have this. I do have this in my speaker deck. Oh, I haven't uploaded this, but I will upload this. I can share it with you all later, either on Twitter. I'll send it to you so you can share it to the Montreal-Python community. I can send the link and upload it. Yeah, thank you for asking.
Yes, perfect. We'll make sure to share this information probably in the YouTube description. We'll update it once we have the information, and on Slack and all the regular places where we mention these things. Excellent. Thank you very much. I think that's it for our questions for tonight.
Okay. All right. Thank you, guys. Okay.
Thank you. Thanks for watching.
OK. Ben, je pense que ça conclut notre présentation. Pour today. Ben, je vais te garder, Yannick, parce que je vais peut-être avoir besoin de ton aide. Juste, ouais, c'est ça. La dernière chose que je veux mentionner, mais attends, je vais voir si là, parce que je veux que les gens nous rejoignent beaucoup et tout ça. Donc, je vais ajouter encore mon écran ici. Là, j'imagine que tout le monde voit mon écran. Ce que la dernière chose, avant de partir à notre... premièrement, pour les gens qui veulent nous rejoindre, c'est toujours... on va aller là, c'est notre after hour. Et dernière annonce, c'est que notre prochain événement, ça va être le 21 février 2022, si je ne me trompe pas de date, Yannick.
Ça me semble pas mal bon. Laisse-moi vérifier mon calendrier. Et oui, le 21, exact.
OK. Ben, si c'est ça, on cherche les présentateurs. Si vous avez ça va être comme on a vu là, comme toutes les présentations, vous pouvez toujours nous envoyer. C'est pour ça que j'ai mis notre email là. Vous pouvez toujours nous contacter par email ou toujours on a notre Slack channel que vous pouvez toujours nous rejoindre. Ça va nous faire plaisir de regarder votre présentation ou votre propos. Tu peux répéter ça en anglais, Yannick?
Absolutely. So our next meeting after today is going to be February 21st, Montreal-Python 91, Exotic Viking. And at Exotic Viking, we already have a talk confirmed, and my memory blanks. Oh yes, it's going to be high performance networking in Python by Yuri Seljanov. Oh my God, I most likely pronounced that wrong. I'm very sorry, Yuri. But Yuri is a core Python contributor. He did many contributions in the async library. And so he's going to tell us how to take advantage of that to do high performance networking in Python. That's going to be excellent. And if you want to talk alongside Yuri and share your projects or your thoughts or whatever you do in Python, well, send us an email at the address that is right here on the slide, mtlpy@googlegroups.com, and we'll be happy to include you in that meeting.
OK, c'est cool. Bon, mais je pense qu'on a conclu ça, fait que on va aller tout de suite sur notre after work.
Super.
Super. Bonne soirée tout le monde. Bye bye.